available to us. Okay. Yeah. Okay. So we can get, let's say, a box plot of Cars 93 price, right? Okay. So you see the way. Okay. This is not nice. I can put in down my margin. Remember, the margin is also in the par, so I can put all of them in at a go. Okay. So when I do that, it's going to, if I now do my plot, it will be a bit wider because I have also demarcated the margins. So you see it's on the left hand because I said my MF row should be what? One row, how many columns? 2 columns. And let's say we want to also see the histogram of this Cars 93. So I do this. And there it is. Okay, so if I want to do it properly, I need to label the S as is. And that is price, right? Oh no. In the case of the box plot, that should be Y, right? We don't need anything for the X, isn't it? Because the price is on the Y axis. Is everybody okay? Yeah, with that one. So I can do it again, and the price comes. And then here, I need X lab. And here, I can just go and copy, and X lab will be the price. Okay. So I do that, and that's it. Okay, so you see, I've put them in one row, but what? 2 columns. Is everybody okay with this? Yeah. Okay. So what I'm saying is that this, as for this, we know what is it. The MAR is a margin. So the MF row is to help you to divide your plotting area into number of rows, number of columns. So before the comma is number of rows. And after the comma is what? Number of columns. So if I have 1, 2, then it means one row divided into what? 2 columns. That's it. And that's what we have over there. So you can create a panel plot like this in there. And when we talk about correlation, we will be plotting something like this. So when we have several variables, let's say we are doing regression, we can plot it so that we have like an upper triangular matrix. So each row you take, that will give you the correlation, either the correlation value or the plot or scatter plot of what? The variable with all the other variables and so forth. So we can get a panel plot like that. Okay. Any question on this? So you can use this in your assignment, right? Because the QQ plot, once you are modifying the function, you must get one for the exponential and one for the Pareto. And you can keep them on the same plot. Yeah, yes. So
for this, you've drawn the box plot and this one.
Yes.
If you are to do additional one,
it will start again.
it will come again.
No, because we said 1 row, 2 columns, so we are done with this. So if I start, if I want to plot again, it will start on a new, and then I must add this. The next one, it will start a new one. If I divide it into 3, then we will also have 3. So if I like, I can go and divide it into 3. But as I said, if you divide this into so many parts, you see, and then I can add a second one. Okay, so the second one, maybe, let's say I do dot chart of the car price. There we go. Yeah. All of them will be on it. But you see, we lose out on the aspect ratio when you are doing plots like this. And that's why I said it's no advice. If you are going to use LaTeX, then for me, I'll plot each single, and then I'll use LaTeX to now combine them. And we'll do so when we do our latest training. Okay, is everybody okay with this? Okay, so now when you are doing plot, I can ask you this in your exam. So practice it with whatever you are doing, so that if I say get a panel plot of all your graphs, then that's how you do it. If you want to, so we can do a 2x3 matrix of plot or panel plot, in which case we have 2 rows and how many columns? 3 columns. 2 by 2, then it will be 2 and 2 and so forth. So it's not that difficult. So explore part if you want to be able to, have control over, or even these ones, we can reduce the font. If we go in there, sex.label will be the label font size. So if it is 1, then it's the default. Anything below 1, it means you are reducing it. Anything after 1, it means you are exploding it, like that. And so there's so many things you can do with a PAR. So just explore as you, and it explains all of it. So if OMA, so if you want to use OMA, it's a vector of the form C, bottom, left, top, right, given the size of the outer margins in lines of text. So sometimes you want to write text around your graph. Yeah, you can do all that. When I was being Professor Leroux, I was wondering what does this man want from all this? So we were to, I have not given that exercise to anybody, but we needed to plot, and when you plot, you put your cursor over there, and I will take the point and draw a circle of this circle. I never understood why, because I struggled to do it. I did it eventually. But all those training were to train you so that you have absolute control over whatever you want to do. Yeah, we don't have much time. I tried to implement the way we did it in Stellenbosch, but I haven't been able to. But what we do was that before the main academic year, you go 2 weeks before the semester starts. So it's intensive, 8 to 5. Old man, but he was teaching 8 to 5, 8 to 5, 8 to 5, 8 to 5. So by the 2 weeks, we have almost gotten the 30. It was 8, like 40 hours. Yeah, 40 hours for a week. Yeah. So the 2 weeks, very intensive. Then after that, every Friday we meet for 3 hours to do assignments and so forth. And the training it's top notch. Yeah, so we will see as time goes on. Here, when you want people to come, accommodation, and the semester is not started, all those, but we will make do with what. Yeah, so you need to explore. Nobody can teach you a programming language so that you become an expert. Because some of the things, it doesn't even make sense until you get to the case where you need some of them. Okay, so for example, what we are talking about now, why should I divide this? Okay, yeah, I can show you some papers where you need that, because you can't be doing graphs all over. In a thesis, you can afford to have big graphs, but in a manuscript or journal article, they want everything to be compact. In some journals, you even pay for the pages if you exceed. Yeah, and it's quite expensive. And even colors for, yeah. So you will say that, well, why do I even need legends with when I can use colors and so forth? So I did not, but you see the lines, you can get line types. So we can use dash line. I did not talk about it, but it's something you can. Dash line, solid line, dash dot lines, and so forth. Okay. Now, in journals, if you use, very soon when you do your thesis, after that you want to publish because it gives you that grounding to get PhD scholarships and so forth. And it's good. If you have done MPhil, you should get at least one paper from your thesis. Now, some of the journals may charge you like maybe $200 per figure. Yeah, but if you have funding, in some universities they pay. Here, nobody has that money to give you. So, yeah, so, but some universities, when you even publish, they pay you. Okay, so when you publish, your supervisor is happy. Because when you publish, I mean, the university will be paid by the government. The university pays the faculty that pays the department, the research, it goes to the supervisor's research fund. So when you want to go for conference, we just take money from that and leave you. Now, back to what I was saying. So the colors, if you have several graphs, it means you are going to pay so much. But you can as well use line type to distinguish it, though that they all have black color. The reason is that when they are printing, now most journals do not print, but some do still print the hard copy. So they pay a lot at the printing press. So they charge you for it. So when you are learning all this, you won't, I did not understand until so when I started publishing it. I said, oh, okay, you need this. So instead of colors, I will not use colors, but I would rather use dash line, dash dot, and so forth. So I'm going to show you some now. Okay, so let's use the bivariate. Yeah, but not every journal charges, right, for the colors. But if you have some that they charge, then you can just use the just a moment. You can just use lines to do it. Dash lines, so and so and so. Let me see if I can get some from here. Okay, so this one comes with color because the journal may not, but you see I've used different colors. So if I send in and they say they are charging, I'll just come back and change the color to black. That's it. But you see, you have this one is red and I think there is green. You hardly see it, or maybe unless you see what is happening. So here, later on, we'll be doing all this. So these are estimators. Okay, so if you look at it, the black one is the one we are proposing. So you see the MSE. From your statistical inference, if you have estimators and you have the MSEs, which one will you choose? What's the criteria? If you have MSEs, the one with the smallest. So this is what we call simulation study. So we propose a new estimator. We need to check whether the estimator works better than the existing ones. Okay, so we simulate observations, we fit the distribution, we use our estimator to estimate it several times. We now find the mean square error, and that's it. So if you look at our own, it is the smallest for every KU. It may not be the same all the time because look over here. The next one is not the case, right? Well, when at the beginning it's not the best, but as you move to the right, what happens? It becomes the best. As we move on, K and so forth, you see now it's not the best. The red one is the best, and so forth. But so you can have estimator. Not all it may not perform across all scenarios. Yeah, but it can have its strength and what weaknesses at a certain point. So one of the main focus of this class and what I'll examine you on is for you to be able to implement a simulation study. in the statistics, which is that when we have estimators, you will be able to actually do a simulation. If you develop any estimator, do a simulation to check that what is being proposed is better. Yeah, so we'll do so as we move on. And the functions will be very much needed when we are talking about simulation studies and so forth. So that's the kind of the thing. And I'll give you a paper that you have to reproduce the simulation study in it. Yeah, so this is what will separate you from, let's say, an applied statistics course in which you are doing almost the same thing. Yeah, okay. So that's it. And this is an example. This is a paper that we are yet to publish. Yeah, so just it's on by Varied, and this is my co-author, Professor Abhay Ghosh in India. So yeah, it's about bivariate tail estimation. So when you have two variables, okay, which are related in such a way, so sometimes we'll talk about correlation, but correlation will take into account the entire distributions, okay, or in the entire data. But you realize that some of them, they may be correlated at the extreme part, and that's what we are interested in. So instead of using correlation, we don't use correlation, we resort to extreme values where we are only interested in the distribution, the joint distribution at the extreme tails, and we call something the bivariate tail index. So that's what this work is about. Yeah, and yeah, that's it. Okay, all right. So basically, whatever we are doing here, like what we did, that's the sort of thing you can use it for when you do a simulation like that. Okay. So, but as I said, you can equally do it by also getting the values, the plot on its own, and then you use LaTeX to put them together. So if you look at this one, you see I have so many plots over here, and I use LaTeX to put them together. It's quite nice than when you use R, but it is important that you know how to do it in R as well. Okay, all right. Any question on this? Okay, so I'm sure you will be able to do this on your own. This part, as I said, we'll do it in LaTeX later on. Yeah, no, but in R, if you have plots, you can join them together. That's what I mean. Can you do so now? Yeah, okay, all right. Okay, so we can move on. Thank you. Okay, so now let's quickly, so today is like a tutorial, but let's move on so that I can get to do something. So our task is to do what? Write a function to compute the BMI. Or let's say BMI of people, or let's say patients, and present the output as a data frame with variables weight, height, BMI, and category. Remember that I said this is basically not statistics, but we can, if we do simulation study, we can even find the standard error of the BMI. If we compute the BMI, okay, if we have a group of people, we can compute the BMI, but how do we put some margin of error on our BMI? We will do that as well, and we can implement what we call bootstrapping to do so. Because we don't know that, if we don't know the distribution of the BMI, we can assume that we always sample from the data, and each time we compute the BMI, and then we use that to find the standard error of it, even though we don't know its distribution. And that's resampling methods, and we'll do that later on. Okay, so what do we do? So first of all, we'll have our BMI. So in this case, we are going to take the function, okay? We will do it gradually. So we do the first one, and so then we'll modify it until we get what? A more refined one. So remember, we said the function needs what? The keyword function, right? And then when we go out, we open bracket and what? End the bracket. Is everybody okay? All right, okay. Then we ask ourselves, what arguments do the function need? We all said it should be what? Height and what? Weight. Okay. So height and what? Weight. So we are done with the argument. Okay. Now, when we come here, what can we do? We can compute the BMI, isn't it? Okay, so the BMI, and we can input in, when you write functions, let's say you are at the workplace, and you want your colleagues to be able to use your function. Okay, maybe you have to write it, but somebody at the customer service department needs to input in data to get a result. So you need to describe or comment what and what you need, right? Okay, so you can either comment outside or within the function, whichever way. So if I'm commenting outside, I can say the height in what? Meters. And what about weight? Weight should be in what? Kilograms. So anybody that starts using that function will know that you need to put in this. Okay. In some cases, you input in a question, right? We can input in a question that is this thing in kilograms. If you press yes, then you enter, then it can now go on. And so R can be very interactive. As I said, it can operate as just any software that you have a user interface for it. And you can deploy these, there are new, like the Markdown, you can use it to create, or the Shiny web app as well, to create a website. And you can explore all this as you move on. Now you can integrate C++, Python script, and work along it. And even Stan usually for Bayesian statistics and so forth. And we can actually sweep. So our sweep documents, you can use R to write a book, right? And you use sweep. The idea is simply this. Now, and you see there's also HTML, which is R to HTML. You can do so as well. Okay, so you can explore as much as you want. Now, if I'm using this if I'm writing a book, right, usually you need example that you work through with it. Okay. Now, if I come back and I change any of them, if I change the data, it means I need to go and change all the plots I have done. Okay, but that's not how to work. So I'll give you the sweep. You can write the book there. Any example that you do, if you change it and you run it, it will do everything again and name it and so forth. Yeah. So there are documents, books on this. Yeah. So R has developed so much that you can do almost everything with it. Yeah. Okay. But as I said, we don't have that luxury of time to be doing all this. But once you have the basics, it's up to you to build upon it. And there are opportunities in there for you to so it is important that you build yourself up. Don't wait when the opportunity comes. You don't have it. Okay, so height, is weight over height squared, right? Okay, so weight divided by is this, right? Okay, so height squared, I can put it like this, or I can write height times height, whichever way. you want it. Okay. So remember that we said for function you need return, right? Do you remember?
Yes.
Good. Okay. So this is a simple function to return the BMI. Okay. That's it. Okay. So let's look at it. We run it. And there was no red marking, so it's okay. So now I can use my BMI fund. Who knows his or her height and weight? You know it. Your height is what?
1.67.
1.67. Are you sure? Are you sure you are not taller than this one? Okay. We have no choice but to believe. Oh, 60. Okay. So your BMI is 21.51. Okay, so let's go to the WHO. So let's BMI calculator. So let's see. Calculate your body mass index. So we are going to check online to see whether they are the same. Whether we'll get your height. We want the height in standard. No, yeah, but I'm not getting. Okay, so centimeter. Okay, so it means we just multiply it by 100. So you said 167, right? So this will be 167 centimeters. Because yeah, okay. And then the weight is 60. Okay, so calculate the BMI. You see 21.5. It's the same. Is that okay? All right. The next thing we need to do is to categorize this. That's what I said. So the category is 21.5. So you see she's in the normal weight. Is that okay? Okay, so now let's go and calculate one for a DSA person. So let's change this one to 160. Oh, some of them weigh more than that. So let's see this one. 57. 83. If you are 83, they won't take you. Which one? Okay, your own. Okay, we'll calculate it, don't worry. So let's go and check over here too. 160, right?
Yes.
We want to see what the 50, so it's the same. Okay, so we come here and check. BMI over 30 is what? Obesity. Okay. So the function we are going to write, at the end of the day, we want to get all this. Is that okay? So that's what we want to do. Okay, so we will now go and do this categorization, which means we have to write a function in there which will compute the category. So we can call that one category. Take the value, check whether it is within this, and do this. Else, the other one, like that. Okay. So that's how you do we do this. So here, whatever we are doing is just like the way they do computer science, right? Okay. I mean, if you're a computer scientist, you can't sit and develop things on your own. There should be some process. And in this case, if you go to the hospital, they must tell you that this is how we compute this, and then you automate it for them. It's the same thing we are doing. So our students, when we tell them that they should, at the undergraduate, you should just focus on mathematics, maybe statistics. As for that one, you can always, but now everybody is, even doing statistics, they don't want to do. They want single major computer science. So if you come out, who will do the processes for you to go and compute? You can't, I mean, everything that they are doing. So if you take, let's say Tesla, They took, maybe Toyota was doing the hardcore one, then they will now go and build upon it. Automate days, So if somebody, the other one, the one below it is not there, you can't build upon it. Yeah, so we should also encourage our youngsters when they come to the university. You can't run away from mathematics because what we are doing now is maths. Yes.
So without this, you can't build an app. I mean, build an app, you put this one inside.
No, the app, you need this one. You can't build the app. There should be some mathematics at the end of the day. So all the apps that they will go and take some engine somewhere to compute it. That's why I said whatever we are doing in now, if we use the HTML, so now we can project it on the web, just like what we are doing now. So here, once you input it and you calculate, it means there's an engine behind this to compute it and give you that one. Basically, it's not because you do some mathematics actually, but I mean what they are doing now ends at level 2 and that's not a good thing to do. Yeah, if you really want to go, because at the higher level it becomes mathematics and statistics. Yeah, so that's it. Okay, so I think now we know what to do. So let's move on. Okay, so it means that this is just. We need to go into our function and what? And modify it to get to what we are doing. Okay, so when we come here, instead of returning just the BMI, I can now start by creating a table. That table will be a data frame. Remember I said we should get a data frame, right? Okay, so I can then put the height, I can then put the weight, and I can then put what? The BMI. Now, so we are still left with what? The category, yeah, okay. So why am I not using matrix? Because the category will be in what? In a nominal sort of, or ordinal in this case. Yeah, so I cannot be putting numeric and some other characters together. So that's why I said you should use what? A data frame. So you see, we go back to our data structures. You can't run away with it. So I now modify this. Let me look at what is happening. You see now, I have height, weight, and BMI. Are you okay? Or maybe I should have done what somebody said. I have changed it, but I made, if you are watching the video, I made that comment, so it will be okay. So you see, yes. So we are going one gradually. So you see, at first we just did the BMI. Now we have added the height and weight. Okay, what we are left with is the category. Once we get a category, then we have all of that. Okay, so what do we do now? We need a function to compute the category. Now, so we can put it inside, but I don't do that usually. It's not a good practice. So when you are programming, what you do is that any little task, you can write a function for it. And that's why I said functions are very important if you want to be successful a programmer in R. So any little thing, just write your function. Then you call that function to do the work and get a result. So we are going to create a new function called BMI category, which will take the BMI value and check with those ranges and output the whatever it is. Okay, so let's see. Okay, so we call it BMI maybe dot cat category. Okay. So such a function needs what? What does it need? What does the category need in order to compute the category? This function. It's what? No. What are the arguments? It needs the only the BMI. So we can put in BMI. Something like that. Okay. Then we come here, we open it. So now we must go to the site and check. If the BMI is less than 18.5, what do we say? Underweight. Good. If it is this, then like that. So how do we do that? Well, there are so many ways to do that. We can use the if statement, or you can use less than or equal to sign to do at all, and so forth. Okay, so let's use the if else statement. So if BMI is less than, so that's the condition. If it's less than 18.5, what do we have to say? No return. The return will be in the function at the last end. So we need something, so we can say that, let's say, category will be assigned what? Underweight. Is that okay? We can come here and copy underweight. Oh, it's less than or equal to. So then we need to do less than or equal to. In R is this. Okay. Now then we need to go to else if. Is that okay? Because that's not the end of it. Else if the BMI is less than what? What will be the next condition? So we can go there and check. If it is less than 20, less than or equal to 24.9. Is everybody okay? Yeah. Because if it is not less than this, it will move to the next one. So there's no need to now do the left side of it, because you can only go to the next one if you that condition is not satisfied. This will end if it is satisfied. So the category will now be what? Normal. So that's normal weight. Is it together? No. Underweight is, underweight is together, but normal weight is not together. Normal weight. Then we need else if again, right? So I can copy the whole thing and paste, and then I do my this one I did not change it. It should be 24.9. Please, are you following? Are you following?
Yes.
Okay, so we go here and check. 29.9 is what? Overweight. So this is 29.9 overweight. I think then the last category. Yeah, so the last category, I don't need any else if, but the last one will be what? Else. Is that okay? Else. Category will be equal to obesity. So now what I'll be interested in getting out of this, all this will be what? What are we returning? What do we have to return? Category, yeah. So we will just write this category. Okay. So after that, we can now run this to see if it is correct. It's correct. There's no, then we try it and see. So for me to try it, what do? I put in what? A BMI value. So let's put in BMI of 19. Normal weight. Your own, we got what? 21. Was it 21? 21.5. Yeah. So let's see. 21.5. Normal weight. And then the DSR person, we got what? 57. So it's working. Okay. So now we can now call this function within our other function and then add the results to what? To our table. Is everybody okay with this? Good. Okay. So let's go into our function. And usually I put this, if you put the quotation marks on the name of your function, it makes it accessible within your global environment and all. So we do it like this. And then I can now come here. You want me to modify it or copy and modify, right? Let me just copy and modify it. Okay, so here I can just call category. I can name a category and then I will say BMI category. And then I put in the value we have computed. Please, are you following? Are you following what we are doing now? So this will now compute it and give it the name or category, right? It's the same thing that you are getting out anyway. Then it means our data frame here will add what? Category. So we expect that now we should, if I do this, and I now give it like this, I should be getting what? A data frame that is made up of what? 4. So let's see. Yeah. Please, are you okay? We can put.
So it's like we are trying to create a table.
We are trying to create a table. But now you see we have a vector. We must find a way to now do this in such a way that we can get a vector passed through, then we have the table. So if you have 100 patients, you can run all of them and then get those who are obese, you refer them to the nutritionist, and other interventions can be done. Please, is everybody okay up to this point? Okay, please, you should.
Where you put in the data frame?
Yes. So I was updating it as I move on. Yeah. First of all, it was BMI, then I brought the height and weight. Now I can calculate the category, so I put it in. Okay. Can we work it out? And then let's see if everything is working, then we move on. So you see, we are still making use of our data structures, data types, and so forth. It's very important. Other than that, if we had done this as a matrix, all the values will be characters. You know that your weight and height will now also be characters. And that's the beauty of using data frame, because you can actually keep the data types for each variable intact. Okay, please run it and let's see. This one you can't be taking notes. You have to do on your own. Otherwise. Yeah, okay. So what's the next thing to do? The next thing is that if I pass in a vector, what do you think will happen? The category will have problems with it. You know, it takes in a vector and then check that when it is checking, it will only check the top part. It won't be able to check each and every one of them. So actually what I will do there is not to pass the vector. I will do that, you see the mistake we'll create for ourselves. And then now we'll use what we call the apply statement. So I can now take the function and apply the function on the data rather. using another format. And that's what I said I'll show you to watch it. There are few things that you need all the time, but let me see. Are you done or you are facing problems? But is the concept okay? Do we understand what is going on? The steps. Then, okay. So we're using the same thing we got from there. If it is less than 18.5, we say, and else if it is less than that. Else if, so basically whatever you pass in here will be a number, right? Then that number you will be checking against other numbers, whether like that and so forth. So you see, if I have added all this into the function, it will be so long. Okay, so I can show you there are programs that I'm writing. I'm still struggling to do some of them anyway. That you see lots, sometimes 1,000 lines of code, but you do it gradually. Every item you do it. There's an equation that I'm trying to solve now, which is very complicated. So you need to be doing it one after the other. I'm still I'm doing it. So if you put all of them together, when you make mistake, you won't even notice where it is coming from. So please take note of it. And that's why we did some conditional. So now the conditional statement we did, you see we are putting it into use now. So that's why when I take some of them, I jump and I come back. It's when we are doing, let's say, if conditions, so you won't really understand why are we, but as soon as we use it in an application, it makes it easier for you to understand what is going on. Are you having problems? Which one? The BMI. So is the if statement okay now? Can I collapse it so that you see the BMI? You haven't. So you must know the concept. Whatever. The first one, you check if it is that. So it means that whatever you want to return, you must be assigning something to it. I could have also, started it with, let's say, ending. So category is assigned ending. Then I now fill it in with whatever results I will get. But it's okay because we are doing assignments. You don't need to do it. But if it's a for statement, then you need to start it with of you is to be able to write this function. You should be right. So that when you make mistakes, no, don't do it. If you see the way I've done it, let it go to the next line. Like, don't write your codes on horizontal. When you make mistake, yeah, you should go with it. So when you get to the end, you press enter, then you move to the next line. Then you press enter. Good. Then you work within it. When you finish, you move out. And if you need me to help, please don't hesitate. Okay. Where are you having it? Okay, so you can do it. But your category is okay. Oh, there is usually the normal way. So go to the category and check. The BMI category. If you go down, if it is under, then you will click go down. Normal. No, you are doing assignment. It should be less than or equal to. BMI less or equal to. Not. This is one line is assignment, so all of them change it to equal to. That's what is causing the problem. You can increase the font size. You can see. Just control with plus sign. Hold control down, then you use. Okay. It increases it. Is it working? That is working. Good. So then you now go to the BMI. So you have it, but we need the modification. Okay. So then you go to the next line. After the BMI. Good. Enter. Okay. Then you need your tab, which is, or you can call your category to compute the category. So category is assigned. Increase the font size. Do you see? What is going on? Yes. Control the plus. The plus. You just go to. So So you see from the little exercise that you, if I put the script there and you take it and you run it, you are not learning. You need to type it yourself. Then you make mistakes and correct it. So when we are in class, please make sure you actually type. What I put there is to guide you that, okay, this is what we are doing. But you must type and make the mistakes. No, this one is the first one. Right? But we were going to modify it, so I didn't want to, so that you know that we started from there. So once you do this, you don't need to go back. You can comment in that one. You must calm down. And you are typing with one and we will go to the program. We have to break her baby say to teach typing. Yes. BMI is assigned. You cannot assign with parentheses. So all what you are doing is please increase your font size. Now see what all these, it is telling you that these are all comments. And you can't do this. It has to be C. Or the function is not there, is it? What were you trying to find? No, but the BMI is not like that. Why are you giving the BMI this? Are you trying to call the function to compute it? Then the function name should be receiving no C. Good. So you have to copy the function. But the function is, you've done something is wrong here. You see, when you write, it should be, I think you have opened, you are doing so many things. You should always not put your, yeah, so this one is the one posting the problem. You can't write and not comment it out. But it will trickle down to all of them. Because that one makes it, so now I've commented it out. You see that, you see it has now changed to black. So now it's working. Good, yeah. So it's because of that. So now, if you do this, the first one you run, you see now that. So if you want to use this, you need to copy this and paste it here. Then it's like you've taken this one, the height is 160, weight is 1. But you see here, this one by 1. You don't need to use not times 2. It's to raise to the power 2. Yeah. And if you want to put this one here, you have to let it be 160 kg. But that's height. You see, you change it. No, yeah, but here it should be the other way around. You get it. So you need to cut this. And then put the 160. You did not retain anything. Okay, you've assigned it. So now if you there you go. something like that. So go back now, do the BMI category lesson. Run the last one here. Okay, so you see, because of the class one, you know you run it as well. So go up there and now declare your function. No, the BMI category must be right. No, you put everything within the BMI. No, take the BMI category outside the function. Copy all that here. Everything, cut it. And paste it outside. Go the press enter. And press enter. And put that one. So that's a separate function. Then you go down. This one you see you have not closed it. So you see now this is closed. Good. So now you can run this. You see there's nothing. And then you can run this as well. Practice. That also works. So now you can compute. Let's say the category, you can now check whether category function. I think it's a problem with no, this is, I think you can see, press control. Press it and okay, so you see, yes, this is supposed to be assigned. You use equal to, don't use equal to. Okay, press that one to be the assignment. And then go to. So do it like that. So this one is a problem. This is actually assigned. And then this one. So the conditions will be less than or equal to. The other one should be. Yeah, this should be else. Yes. You just else. Because you can only get there if your weight is not less than 80. It's not less than that. It's not less than the last one. Everything else. Yes, so don't, the 57, you don't need to state it. Because somebody can go to 100. Look at the sumo wrestlers. So you don't limit it to 57. They said, no. What? Okay, so this is correct. 57 is obesity. So we rerun it and let's see. Yes, the 57. Okay, so you see now it's working. Yeah. So it was those equal to and less than or equal to that was possible. Are you done? You. Okay, when I'm typing, you have to type with me. Is everybody done with the category one? This one. You must check whether it works. You put in some values like I did. If you are done, then we can now move on to what? The BMI. we get all our this, that, and then we move. Please, are you done? You can't extract the table. Why? No, go back. Which one do you want now? Oh, but you have not done it. This. Return. You have not returned anything. And you cannot return BMI and then the return should be the last. So delete it and then you return the task. Yes. So you must come down to the tab and return the tab. Yeah. And then you rerun the function. Yeah. You can. No. It is not like that. So we have to round it at the when we completed the video. Yes. So no here. So you go to round it. It's a good thing. Let me do it so that they all just see. Okay. So there's a very good observation about decimal numbers. So let me go in there. I'm going to modify the function to get the decimals correct. Remember that when I did my own, look at the results. You see the BMI, when I compute something, it will usually leave it in 5 decimal places. But the others were 2 decimal places or no decimal. So I can put all of them in 2 decimal places. Is that okay? Even with here, that should be fine. Now, this data frame has, we can try, it may not work if it doesn't, because of the obesity. Okay, but let me see. So I round it, dig it, it's equal to 2. It may not work because of the, but let me try and see. If it works, we are good to go. You see what I said? Because we are now trying to non-numeric alike. So what I need to do is that instead of rounding the data frame, I can just round the BMI. Okay, to 2 digits. Or I can do it here. I don't like. Okay, so let's do it here. It will be better. We can also do it within the data frame. We will just put the BMI into round 2. You round the BMI into 2 decimal places. But now what is going to happen is that we are going to get the BMI into 2, but the weight is not in that 2 decimal places. We can round it off as well to 2 decimal places. How do I do that? It means the time that I'm calling weight, I can also round it into 2 decimal places. Or I create the numeric part as a data frame on its own, round it, then I add the category to it. That's another way around out. So it depends on you and how you want to do it. Okay. All right, so that's it with this one. Please let's hurry up. We must do the vector one, then we can go. It's even time. Okay, so let me do that. And I think if you get the video, you can just, today I'll do it here before I leave. Because as soon as I leave there. Yeah, so this one now. Okay, so let's see. You see, if, let me get height. So height, I'm going to sample from, let's say sample, would that be, okay, so I'll, you know the uniform distribution. So what I sent you. So now I'm going to sample observations from the uniform distribution. So I use RUnif. sample size. So maybe I want 10 people, their height. So I'm going to sample from, let's say, 1.4 to 2.02 uniformly, 10 numbers from it, right? That will be the height of the people we are dealing with. So that's how we do simulation. You simulate, you mimic real life. I could have asked you 167, then we type, but I can also simulate. So it says you need n is equal to what? 10. I want 10 people. What is the minimum height you want? 1.40. What is the maximum? So I can write min is equal to, what is the maximum? Maybe 2.02. Is that okay? Meters. So when I do this, we all do, you can get your own. You see, you get different results. Okay, I can round this to what? 2 decimal places. So if I want to do that, I must put this in what? Round, right? And then I put the digits is equal to what? 2. And then I do this. So now if I display this, I'm going to get different results anyway. So this means I have simulated observations from what? Height from a distribution that is or uniformly between 1.4 and 2.0. Okay. What about weight? I can also use a uniform distribution, or I can also sample 1 to, no, not 1, we don't want weight of 1, but the weight should be maybe from 50 to 160. So I can get numbers 50, 51, 52 up to what? 160, and then I sample 10 from it. That's also another alternative. I can also simulate it from a uniform distribution, okay, or even exponential, whatever distribution you want. But in this case, you want to limit it, so you can't be using a normal distribution. Okay, if I use a normal distribution, hardly will I get it truncated, unless you are using truncated distribution between what? 1 and 1. But uniform presents us with a good candidate distribution to sample, or we sample from numbers itself, whichever one is okay for you. Since we are using uniform, let's use uniform again for the weight. So we change this one to weight. You see, I just copied. So 10, but the minimum will be what? 50, right? What will be the maximum? Oh, sorry. The maximum is what? 160. And the digits is 2. So let's see this one. The weight. There it is. So it's like now we have brought a machine here to measure your height and weight. So we now have a sample that we want to do. Okay, now if I call this, what I need to do is not to provide it with numbers, but just put in height and weight now. I can delete it and wait because I have declared this, it will take it like that. Alternatively, so let me see, we are going to get an error as I told you, and this is the reason. It says the condition has length greater than 1. We are passing a vector to the category. Remember the category, we only take BMI, but now the BMIs are vectors, right? So it will take the first one and it will tell you this error, that error in if. If you want to use if, it means it must just take in one object at the same, at the go. One. So I'll have a workaround on that soon. Okay. Now, what was I trying to say? Then we could just say height is equal to the height we have done, right? I'm using the same thing, but it could be any value or any name. Like this, we are going to get the same thing. So what I need to do is that I'm going to now, instead of passing BMI like this, what I'm going to do is to modify this. So I'm going back and I'll put a comment there, modify it to calculate or to is it computing? Okay, to compute category for vectors. So that's a vector with more than one object, right? Or more than one element. Okay. So in that case, instead of this, and please check, or I'll put it on your. So instead of this, I'm just going to use what we call the S-applied. It's part of the applied family of functions. I've done a video on that you can use. So instead of this, I'll just call the BMI. So you see the BMI that I've computed will now be weight. It will take, that's for that calculation. It can do it in a vectorized form. Okay. So I can just do this for you to see by just, because it's weight and so you see this BMI, it will now be a vector made up of 10 objects. Because it takes its height and do this. So you can actually work within your function. Okay. Usually when I'm working, I do that to make sure that I work before I put it in a function. Yeah, but this is very easy. So you can. So now I can calculate this, and I'm going to get 10. Okay. So that's it. And you can check the 37. 37 is obesity. 61, that's obese, and so forth, obese, and so forth. Okay, so that's how you do this. So if I go back and I do this, it won't work. You see, that's the error we are getting again, because we are passing a vector through an if function, which it won't work. Please, are you okay with what I'm saying? Yeah, so if we want to vectorize it, we resort to the apply family of functions. And I'll send the video to you, and then you can watch it, and you will. So that's the only thing. Now, it means that I need to go back and rerun this function for it to take effect. Other than that is the old one. That's there. Okay. So I run this, and then now if I come back here, and I'm going to get my data frame in that order. And that's what we wanted to do, right? At the start. So we have our data frame. When we do our LaTeX training, we will pass this through an S table, and it will generate a LaTeX table for us, which we can copy and paste in LaTeX and run it, and then we get a table. So that we don't need to do this. If it's in Word, you have to pick this and go and create a table on your own. But later we'll get a source code, and then we pick from R to LaTeX straight away. Word, you can't do so. So that's why we don't encourage our students to be using Word to write thesis to write, or PowerPoint to do presentation. Okay, so that's it. So let me send this to you. But is the concept okay? Yeah. So what I went in there to check, to modify, is to be able to use what? A vectorized form. That's it. So the old one is here. This one is, let me put in another comment, which is only one value at a time. So this one, if we use this, it will only take one value at a time. If you pass in a vector more than one, it won't take it. Yeah. So to do that, we do this. So what is this? You just take the object. As a matter of fact, when you watch the video, we can use it to work on rows or columns. We have the apply, S apply, L apply, and they are very helpful when you are doing simulations, because it allows you to work through data structures quite easily. Okay, so that's what I'll add to it. So I'll send you the video and the script. Please make sure you go through this, because today we did only tutorials. So you should sit down and be able to know the concept. Yeah, it takes time to grasp this, but it's only through practice. There's nothing else we can do. I can do this, but I have been doing this from 2011. So, so, yeah, so if I'm working fast, it's not, I mean, I've been teaching this from 20s, almost every semester. Yeah. So you learn around it. So it needs practice. Yeah, so that you get to know otherwise how can make your life quite difficult. I still have difficulties to solve that up. Yeah, so I mean, you never finish learning a programming language. Yeah, and it's because, we are doing statistics, you have issues in statistics, you are trying to program, put it in and I can show you some of them that we are doing. I mean, it takes a whole lot to do that. Yeah. So please make sure you do so. And as I said, there are opportunities. I mean, if you know aside from the your thesis that you need to finish so that we can hand you a degree. There are other opportunities. You can train people in it. Because, I mean, for now, almost every... so I want to show you something that we are solving now. So... okay. So... so this is a manuscript we are writing, which is divergence-based tail index estimation and a random truncation. I think I explained truncation over here the last time. Good, okay. So this is some work that I'm doing with my supervisor and another a co-author from Algeria. Now, look at the problem we have. So you see, we start from here. So all this, you have to put it in a program. Okay, so this is what we call it's divergence, the minimum density power divergence. So you have a data set, right? Now that data set comes from an unknown distribution. Okay, but we can use the data to get an empirical distribution. So what is this density divergence? That we know the density of the data as we speak now, but we don't know the real generating function. So what we can do is that we can limit the distance between what we know now and what we don't know. That's the concept. And it turns out that you can actually limit that distance. Okay. So eventually, if we use that principle, we are able to now formulate this. You say, hey. You say there are many. Okay, so this is what we are trying to solve now. So it means I need to program this, okay, so that when I have a data set, okay, I have a data set that have distribution F, that is unknown, right? This distribution is being truncated by another distribution C. Okay, and so for that it turns out if we solve this equation, we are able to estimate our the parameter of interest, which is eta. That's value, and so forth. But we'll get to some of this, not into mad details like this. But I mean, in your MPhil, we can tweak some of these things, and then you can write on it as but this is in extremes. Okay, all right. So that's where we want to get to at this level, and then
next semester we'll continue.
No, it's only this one. No, it's just a concept. Once you get it, but this one is solving an equation. We know we have two equations over there. So here, you see, if my alpha is greater than 0, I use this. And the alpha is a robustness level. So this is a robust estimator. Okay. So if my robustness is 0, then it's like the maximum likelihood. So it uses this one. So what you need to do is to solve this equation. But each of them is also, it's also an equation. or has an expression that you need to. And that's what I was saying, that you need to be able to develop the habit of, writing a function for each task. And so the programming that I'm doing, if you look at it, you will see that each no, it's not here. We'll get there. So each of these, if I take, let's say, L alpha, if I track back, you will see what function that L alpha is. Okay, so the F is like this. This is the Woodruff estimator. So it's a form of an empirical estimator. Okay, so it means that our F, you see that if I take a data set X, I have to find the product for all this. And I write a function to calculate just the F. I write a function to calculate the C. I write a function to calculate the L alpha and so forth. So that's how the C is of this form and so forth. So that's how things are. That's why I said in R, if you know how to write a function, you are good to go. And that's what we have been doing now. Okay. So you see, if I have the differential of the L alpha is this. So if I see a differential in there, it's the same as writing a function to compute the right-hand side of this equation. Yeah, and each of them, I write a function, then you call them like that. So if you make a mistake, then you can go there and correct it and move on. Okay, all right. Okay, so next week, I won't be around, so I'll have an online discussion with you. There's a video on, we will now go back to some statistics. So we'll start with hypothesis testing now. So all those basic undergraduate hypothesis testing, we'll start going through, because these are also important to us. So once we finish with hypothesis testing, regression, what have you, then I'll now come to simulation studies, where we'll do some of these things. Not, that to this difficulty level, but to be able to, we'll start with, let's say here, like the 333 that we do, and then you get to what Professor Note is teaching you as well. So that's what we want to get to. But to get there, you must have the basics. So please, just when you get time, just if you go to the YouTube page, there are so many, even the undergraduate ones. The one in Maximum, like, it's the same thing we are doing. You go there and polish your the basic ones, so that when we get to the more difficult ones, you are not left behind. Okay, all right. Okay, so enjoy the rest of the evening as I go to my next class. Let me do that before I go. Okay.
What's up?
Hi, Jira.
You know,
We brought.
Okay, so